Yeah, we're about to restart as soon as I can open the slides. That didn't work out. This looks better. Okay, if we everybody can retake their seats, then we'll start for the last session of the day. As I said, we've got three presentations left, and the first one is by Paolo Lucente from pmacct, and he's gonna talk about network traffic telemetry, as he's called it. So, how to deal with net flow and other sources of information, and the usefulness on processing that data. So, Paolo, go ahead.
Hi, good afternoon. So Paolo Lucente from the pmacct project, and welcome to half an hour, let's hope less, of Italian English over here. So I have two items on the agenda for the presentation of today. So very short who I am, and then we go to the core of the presentation. So let's say making measurements, why, what methodology, why you should venture into something like that or you should not. And so we go really from square zero to reporting. So I've been working for many years at service providers, and after that it's roughly a couple of years that I'm working for vendors, and one of those you really love him. And let's say I've been involved with IP accounting for really all, since the very beginning of my career. And that's why, let's say in the 90s, I stumbled upon NetFlow. And at that time, let's say my first task was something like, you have half a meg of connectivity for a whole region of Italy for one provider, and then you have a lot of connectivity between, within the region, and then you have to, partition and see who is consuming how much bandwidth, because the one that will consume a lot of bandwidth will pay the next upgrade. So I was more or less, I had that task. So everybody wanted to be my friend because of that. So let's say I want to start, let's say, this presentation with the fact that, let's say, NetFlow and traffic measurements and telemetry are very often just connected to security. But I mean, over the time, at least to myself, I mean, I was involved with NetFlow in very different things. So NetFlow is absolutely not only about security, about DDoS detection and things like that. With NetFlow, you can do much more things. The ones that I did were traffic engineering, capacity planning, peering, and of course, peering analysis, and of course, also security. So let's try to destroy this misconception that I still find today in some, for example, in educational environment. And because I was, I told you that it's many, many years that I am involved into this. This is my contribution to the industry, which is this pmacct software, which is open source, free, GPL, and independent, right? And you can check it out at the URL over there. I will not tell you more because on Tuesday we have a tutorial about this software. So, if you really want to know more about it, then come on Tuesday. And so let's start with the real, let's say, presentation, which is, let's say, so square zero. Let's start from the very, very beginning, right? So many people, when we speak about telemetry or measurement, they think that a NetFlow is the only existing protocol to do that. Actually, that is not true. And we have NetFlow, which is, let's say, a Cisco trademark, and that's why, you know, when router vendors implement NetFlow, they tend to use a different name, which is typically confusing for the users, because one of the popular questions is, my router exports JFlow or my router exports CFlow. Do you support that? And of course, I mean, JFlow, it's the same of NetFlow, and CFlow, it's the same, you know, it's just an alias for NetFlow. But let's say next to NetFlow, let's say there is also SFlow, and there is also IPFix. And as of last week, we have a great news, which is IPFix, which is the ITF effort to standardize telemetry protocol. I mean, IPFix, as of last week, became a standard from ITF after many years of effort. So definitely, I mean, NetFlow, it's not the only protocol there. So let's say what would be a key difference among, you know, the main measurement protocols out there. So NetFlow works by, you know, traditionally works by building a cache and identifying a flow by, you know, 5 primitives, which are source host, destination host, source port, destination port, and protocol, and TOS. And that was at the times of 10 years ago, NetFlow v5, NetFlow v1, NetFlow v5, v7, and things like that. And then things evolved over time, and then we have NetFlow v9 or flexible NetFlow, by which essentially you can generalize this concept that you have a cache on the router by identifying a flow or a record by whatever set of primitives you want. So once the flow is in the cache, counters are accumulated, and then the flow is expired or released to the collector. And SFlow works by in a fundamentally or in a slightly different way, I would say, by which you have an interface, and in this interface, you know, packets are passing through this interface, and one out of n packets, well, one out of n, you configure a sampling rate, and there is random sampling, you know, made out of it. Let's say a packet is sampled, and in a specific data format, it's sent to the collector. And then you have IPFix, which is, you know, this ITF, you know, standard effort that now became a standard. And many years ago, there was a beauty context, right? There was a beauty context at ITF by which it should have been decided what is the foundation of an ITF protocol for network measurement. And let's say NetFlow v9 won the beauty context, and that's why IPFix nowadays, it's very similar to NetFlow v9, but with a few differences. One of those, very, very important, is that variable length record can be sent over, which, if you think a little bit about it, it's a little bit going for a network measurement protocol into the field of syslog, right? Because you can start sending strings, you can start sending events through this protocol. And this is one of the trends, actually, which is happening in this. So let's say these protocols started as, let's say, very, you know, static kind of protocols at the very beginning. And the consistent trend now is to build modular protocols. So you have SFlow, which has modules, and then NetFlow, which has templates. So you get data records, but then a template to describe what is in the data record. And that means that then you are not limited anymore in what data you can put into those records. And so the first question comes, I mean, what protocol should I use, or what protocol can I use? I mean, you don't have a huge degree of freedom over here, right? Because at the very end, the protocol you can use is mandated by your vendor. So if you are with Cisco, then it will be NetFlow. If you are with Broadcast, it is SFlow. If it is Juniper, for example, you are in a mixed ground, where essentially for MT and MX series, you can use NetFlow. If you have a service card, you can use NetFlow v9. If you have some other cards, you can use IPFix. So it's a very complicated story. And then if you have SFlow, if you have EX series, so this which is you can use S-Flow. So the vendor and the platform and the model of the vendor is actually mandating what you can use. And if I can be a little bit extreme on this, do not let any vendor that has not, telemetry capability sell you some network equipment, because then you will cry afterwards because of that, especially if it is an edge device. And so what is another consistent trend with these telemetry protocols, right? So that it's what I was saying a little bit before. So that they are being generalized, right? And generalization is a consequence of, modularity that I was explaining before. So traditionally, they were all about traffic measurement. But now, for example, NetFlow, it's entering a lot, and IPFix, by consequence, it's entering a lot into firewall and NAT events, right, in reporting firewall and NAT events. But for example, S-Flow, it's doing the same with VM resources. So you can really get, some, disk utilization, memory utilization, and CPU utilization being reported via S-Flow from some VMs. And so that means also a lot of pressure being put on the collector, right? So scalability of the collector, choosing a collector that can scale, it's of topical importance, right? Because if you think about it, if we are in the field of traffic flows, you can have thousands, 100,000, or a few millions traffic flow per second, and that's okay. But if a carrier-grade NAT blade is resetting for whatever reason, then in one go, with the current numbers, you can even get up to 80 million records being sent on the span of a few seconds. So that is really, massive. We really speak about a gigabit Ethernet, which is very well utilized, and it's full of data to process, right? So let's say that we did a very nice introduction. So let's say you own a network. You are a service provider. So what is the very first recommendation, right, for venturing into into network telemetry, right? Because if you already tried, you already know by now that it's not like SNMP, that you just pull a switch or pull a router and you get statistics, right? It's something that doesn't work, at the first time. You have to put some thinking, and it's a quite interesting process. So first of all, start top-down, right? So your methodology should be top-down. So start with a vision, because the moment in which you have a vision, then you have goals. And from then on, from that moment on, then it will be all, I would say, easy. I mean, you will have technical challenges to solve, but you have a good idea of what you can do. So don't venture into, collecting, traffic measurements with NetFlow and things like that, if you don't have anything like that, if you don't have a project, if you don't have a business case for doing that, if you are not sure that you really need to do peering analysis or things like that, because otherwise it will just be a waste of time, right? You will end up saying that I want to collect every data, every microflow that my network is generating. I want to collect it. Why? Just in case. Because you don't have a goal, right? And so you will see very easily that you will end up with billions, trillions of records, and then what? Are you able to process that? And if yes, how long does it take, right? Can you sustain that? So that is very important. Start with the vision, and so your goals then will drive to requirements. And if you can line out requirements, then I would say that a good part of the job is already done. So let's start. So let's dive into these requirements, right? And let's say we said you have goals, and of course you have got a network, right? So the first part to measure, traffic from a network, it's to configure the network to export traffic, right? I think it's quite intuitive, I would say. So you should define, first of all, an export model. So there are some very popular, things that you should check out when you define the export model. So what devices should export traffic? what interfaces of these devices should export traffic, which direction, right? Inbound, outbound, both of them. And do you need sampling or you don't need sampling, right? So the first thing is that when you define an export model, so for example, you say, I want to collect net flow at the edge of my network on all the interfaces facing transit peers and customers, do reality checks. So do not just assume that your vendor will follow, what you have in mind. So lab things up, double check. For example, it could happen that some interfaces are layer 2 interfaces. You have VPLS to your customers or things like that, and NetFlow will not work. Or for example, egress NetFlow. NetFlow, it's something that is, it was originally an ingress kind of technology. And so egress NetFlow is supported by many platforms, but still today it's a bit of a taboo. It doesn't always work, right? And then there is one other thing, right? So which is that you might have heard, for example, of the likes of flexible NetFlow and things like that. I was mentioning it before. So it's the freedom to choose what you want to see into a record. And, but don't assume that your platform will, will give you the flexibility to export flexible NetFlow. Check if that is the truth or not. Because what happens very typically is that the higher range platform, they are just designed to, crunch packets, crunch, crunch data, not to be featureful, right? So the more you go into higher range platform, the less features you will have, and you will be hit if you do assumptions on what the hardware can do. So another important thing about requirements is, let's say, network telemetry, right? So with the moment in which you collect data with NetFlow or SFlow, is that all, or you would like also to correlate this data against some other source, because you can do that, right? So you can do correlate, for example, against BGP to get more visibility into the interdomain, routing, or against the EGP to see better what happens within your core, or against anything else that you can think of. So is network telemetry only going to help, or you need some other source of data next to that? And there is any margin to use data reduction, right? So because the moment in which, so why, or maybe you can put it also the other way around, do I really need the microflow information for my task? If it's about security or research and development, yes. Otherwise, you can build a data set, and you should really work in a project-oriented fashion. So build the minimum data set that you need to achieve your goals. You can even build multiple data sets. That's very good. That's very fine. But just don't collect everything and dump it to disk, because be gentle to your data, right? So let's say the moment in which you have laid down, let's say, your vision, your goals, and your requirements, then, you can go through a selection and understand what tool fits your need or your bill. You can choose what storage you want to use. So the storage is a little bit more into the area like, I want to do it myself. I don't want to buy a solution from somebody, right? And we will see it later. But let's start from what are the hurdles that you will be hitting, when venturing in such a project. So first thing is that it's organizational, right? Because let's say that you are the guy with the vision, and if you are the guy with the vision, you are most probably a network engineer, a network planner, network architect, CTO, or whatever. So first thing is that you have to let the network export, let's say, data. So you have to get through, let's say, the network operations. And then maybe between the collector and the network, there is a firewall, so there is a security department. And then there is somebody that should set up your VM or your PC where you should collect the data. And so maybe there is a system administration or IT or both, maybe. So as you see, it's a lot of departments, different people, different languages, and so it's very easy to get into an 800-pound gorilla project. So think, to your health and to your wellness before venturing into this project. And then there is a lot of technical things, because I was saying that network telemetry, it's not really like SNMP that you switch it on and it just works. So at the very end, I mean, a lot of things can go wrong and need troubleshooting. So there could be network exporters, so routers that lose data along the way. Why? Because you are exporting too much, you need to sample data, and so your export is being throttled. Or for example, collector, it's not scaling very well and you lose data at the collector, or your network is losing data. But I suspect that in that case you have different kind of problems, right? And then there is also some over-engineered, let's say, features that make it a little bit hard, right? So the bottom line of this, especially on the technical part, right? So because a lot of things can go wrong, verify your expectation against an external method. For example, interface counters, you can always consider them like the golden truth. So either manually compare that what you get from the network telemetry is the same as SNMP. It will always be a little bit underestimating, but see if it's underestimating too much for your needs. Or otherwise, I mean, do some automatic checks. And in that case, you can also work out rescaling factors and, you know, beautify what you get from your, you know, network telemetry. About scalability, divide and conquer technique, it's absolutely fine. And you have to keep in mind that especially if you have a mid to large deployment, if you are so a big to large network, you might need at some stage or another a big, you know, a collector, you know, to scale horizontally. So you might need more than one collector. How to do that? Divide and conquer, so horizontal scalability. You can partition your network, assign routers to collectors, and then if you have a storage which is not embedded with a collector, then you assign the collectors to the storage. That's perfectly fine. At the very end, you end up with several storages, and you can do very nicely your analysis. Other two tips about the scalability is data reduction. So study what if you really need microflow data, or you can aggregate your data. You can do aggregation at the exporter, or much better at the collector. You can, let's say, do sampling, and then you can do essentially aggregation on the temporal axis. So fit data into time bins, right? So do you really need to know what is the exact start time to the second or to the microsecond of a flow? Or you can fit all your traffic into time bins, 5 minutes, 1 hour, 1 day, right? And of course, you can always remove from the equation, let's say, I mean, interfaces that you don't need. For example, because they are low speed, or because you are an internet provider with eyeballs, and for example, you are caring a lot about inbound traffic, but not much about the traffic which is being sent back to the internet. Storage, there is a pretty much on, you know, on offer in terms of storage, right? Every product comes with different storage, let's say, selection, and open source tool freely available also give a lot of, you know, they offer a lot, let's say. And so you can count relational databases, non-relational databases, message queues, memory tables, flat files, and whatever. So I do not come, so both myself here in this presentation and as, you know, the principal developer of the pmacct project, here I don't come with a position, right? So you should prefer this or you should prefer that. Because at the very end, there are two, you know, things that so as a software developer, I give the freedom for everybody to implement the storage that they want, right? I give the maximum offer. If you saw in the slide, wow. If you saw in the initial slide, I mean, about the pmacct project, you have a lot of output that is possible. So there are typically two factors driving the choice. So one is whether, I mean, it's really technical, right? So if you want to store microflows, of course you don't go for a relational database, right? So we are in the obvious over here. So there are choices like that. And the other is personal preferences, right? So there is somebody that can just do not live without SQL language, for example, right? They want absolutely the flexibility to relate things and have lookup tables to relate data and things like that. So at the very end, those are the two drivers: personal preferences and obvious technical issues, let's say. And then let's say that at this stage, we went through the requirement, the selection of the backend, the selection of the collector, and the vision, and you have the network, and you configure the network for the export and things like that. So let's say that at some stage you lab everything up and you put it in production. So are you over? So the project is over and you can just move to the next one? Maybe yes, but before that, let's take a look to two arguments, to two topics, sorry, maintenance and reporting. So first of all, I mean, the network is very dynamic, right? You add new interfaces, you add new routers, you remove interfaces, you remove routers, right? So there is at some stage that there is the ideal moment when everything goes in production, that let's say everything is working beautifully and you are happy about it, right? But then, of course, mistakes can happen. A new interface is added, and somebody enables NetFlow, and then suddenly you are getting duplicates. Or somebody is, removing from a customer interface or from a transit interface the NetFlow configuration for whatever reason. You don't know, right? And so the ideal situation is going to break up, right, over time. So that said, let's say mistakes are just around the corner. So what you should do really is to track, to have an expectation of the NetFlow or the telemetry that you are going to get, and you should really verify that you are getting the full data set so that the coverage keeps 100%. And if not, at least you have a mechanism to trigger that alerts you that something is going wrong. And the same, of course, also goes for disk space utilization, right? Let's say you want to build scripts and things like that to keep under, let's say, to verify that utilization, so resources of the collector are well utilized. First of all, because the divide and conquer, that's the foundation of the divide and conquer. You understand when you should add, a new collector. And for what regards disk utilization, right? So at some stage you should expire data because you don't want to keep data forever. And this is the point that I make in this slide, right? So you can do it typically when you want to expire all data, you can do that in a couple of ways. So one is that you build one data set and then you consolidate it, right? So you build 5 minutes data set out of 5 minutes samples, and then at some stage you consolidate these 5 minutes into 1 hour samples and things like that. So it's a consolidation, sub-aggregation, call it whatever you like. But this is a very expensive operation, and I totally recommend against it. So what I recommend you is really to waste the disk space, a little bit of disk space, which is cheap anyway, and build a separate data set for all the data points that you need in time. So build in parallel the same aggregation, but for 5 minutes, 1 hour, and 1 day, for example. And then at the very end, you have only to delete data or drop a table or delete a file, for example, right? Much lighter operation. And my penultimate slide, so that I can fit in my 5 minutes remaining, let's say reporting. Of course, reporting via web or via email, or especially web, it's very popular. And at the very end, I mean, what you should really take care of is that, let's say, flexibility must be possible, because if you put in place a system that collects network data, if you're successful, then everybody will be just behind your door. So from sales to product management to purchase and things like that, because then people will just want new reports. So still you will be in that ideal situation at some stage where you are building all the reports you need, but then very soon somebody will come with new requirements and you will have to produce new reports. So it's key that whatever you are building or you are buying, it's able to follow that flexibility. And especially important is what happens to backward, data from, you have a requirement today, you are adding a requirement today, what happens to last month of data? Can you really, analyze that or not? So maybe a good strategy is always to build several data sets to fit your reports, and as a backup, and only as a backup, have raw data so that you can query or you can test against it. And the moment in which you get the expected results, the expected reports, once you validate that the report is really effective, then you can produce yet another data set to produce that report. And then finally, the holy grail, of course, is that people is looking for that web front end that is doing everything. So from DDoS detection to peering analysis. I mean, you get the data like you want in the backend, and then once it goes in the front end, you can do everything with dashboards and graphs and things like that. So I think that many of you, if you ventured into this, maybe you can conclude that the Holy Grail doesn't exist, right? And my position on that is that the powerfulness of a measurement system, it's really lies in the data. And once you have the data, once you have the right data set, then building a front end to analyze that, to show that data, let's say it's the minor part of the job. So one thing that really happened at the RIPE meeting in Dublin, while I was speaking with a French guy, very, very interesting, is that he uses pmacct, and he showed me, a very nice interface in which he had charts and a lot of stuff, right, and tables and whatever. And I said, wow, where did you buy this? And he told me, oh no, I mean, in just 48 hours, I put this together with the Twitter Bootstrap. I mean, and he is doing totally different stuff, right? So, and I have to admit it was very true. So maybe if you are still in the look for that holy grail, maybe consider also whether you are better maybe to build something in-house yourself for your specific needs. And maybe web technologies are evolving, and it's not that you should really start from the scratch, and it's easier that you can think of. Thanks very much for listening to this half an hour of, I hope it was any interesting, and any questions.
Thank you, Paolo. Any questions for Paolo? I know it's getting late. Anybody here running NetFlow or SFlow, or what's the name of the brand here? We have a few. Using his tools?
So, okay.
Okay, well, thank you.
Thanks very much, and come on the tutorial on Tuesday if you want to know more about pmacct.
Yes, he's right. There are tutorials, and this is one of them. So yeah, be sure to be back on Tuesday. And in case you're wondering, all the slides are online as well on the MENOG website, so you can download a copy.